Welcome to my third lecture on data and statistical learning in R, and in this lecture we're gonna to cover two topics from statistical learning. The first topic is about validation error and cross-validation. Actually, this concept is essential to understand the basics of how machine learning or statistical learning methods differ from traditional econometrics and or statistics. So we're gonna discuss this topic, and then we will move to some classical, I would say also a bit old-fashioned methods for selection of the best subset of variables for in our model. And in this selection procedure, we're gonna use those validation and cross-validation errors. Yeah, so those are those two topics that I'm gonna discuss. But before that, I will show you the solution to this assignment. Yeah, so as if you watched the previous lecture, yeah, I asked you to at least to try to solve this. This assignment, and now I'm gonna to present my own solution. Yeah, so that's the plan for this lecture. Okay, so let's start with this assignment. Question 1 is just a warm-up. Yeah? So here we have question 1, and in this question we are asked to write a function that computes the area of points enclosed by a circle of radius r. Yeah, so here we're allowed to use the analytical formula, and we create function circle with argument r, input argument r, and we return pi times r squared here. So now we have to load this function to the memory. And that's it. Yeah, it works. In question 2, we are asked to do the same thing, but we should use the Monte Carlo simulation that we already learned before, and so let's do it this way. Yeah, and the function circle MC, and here in the admittedly in the question I provide that I want to have only radius as an input, but let's take radius and number of points that we use in our Monte Carlo simulation. If you set some fixed number, it would be from my perspective it would be fine, but let's do it this way. Yeah, and now, yeah, the only thing that we have to draw is that we have points. We draw endpoints from interval minus r, and this is for x's, and for y's we do, and for y we do the same thing, and we bind those two simulated coordinates of points of endpoints for x and y. Yeah, and all those points are drawn from square of x's and y's from interval minus r, minus r, r. Yes, so overall the area of this should be the area of this square should be equal to 2 times r to the power of 2, which gives us 4 times r squared. Yeah, and so this is it. And now area we create vector if else, and now points. The first column we use the formula for circle, and we compare whether the sum of squares of coordinates is smaller or equal to r squared. Yeah, because this is this formula for circle, and if this is smaller, then this is 1, otherwise this is 0. Yeah, and this is how we create this vector, and now the only thing that we have to return is return number of points, area. So those points are inside of our circle. We divide this by n. This is percentage of this initial figure, this initial square that are inside of our circle. Yeah, and we multiply this by the area of the square, which is, in our case, this is 2 times r to the power of 2. Yeah, which, if we take this, we could write this 4 times r squared without brackets. Yeah, so that's the function. Okay, and now if we write circle MC1, it returns here something here which is not that far from our pi, yeah, because for 1 it should be pi. If we increase this, we're getting closer and closer. Yeah. Let's wait a bit. Yeah, it's better and better. Yeah, so also here we can provide other numbers. Yeah, other values. Yeah, this is question 2. Question 3 is quite similar to question 2, but in this question we are asked to compute the area of the figure. That, yeah, you can find this over down there, and this area is circle except of this quarter of coordinates for which x's and y's are positive. Yes, so we can reuse our code from the previous exercise, question 3, and let's create the name should be frac. Okay, and before we create the function, let's use this without function, because I want to show you something. So right now, if we type so here n we assign, I don't know, n equal to 1000, yeah, or let's change this here, because before in the previous function, yeah, it was taken as an argument. Now I took this code outside the function, yeah, so that's the reason why n is not found. And let's create this. Wait a moment. And also, yeah, and also with r is the same thing here. So here, and now it should work. Yeah. So now I draw points from this from this square, and I create area, and now I want to plot those points with color. If else area equal to 1, then I want to have this green, otherwise let it be red. Okay. So here, yeah, it's not perfect because this aspect ratio is not equal to 1. If we type this, it should be much better. Yeah. So with aspect ratio, yeah, and now we see that this is the result of our code, the result of reusing our code for plotting. And now we could think that apart from this condition, we want to have that points, that x's are non-positive, or y coordinates. Yeah, and if we write something like this, we won't get exactly the same picture that we have in the exercise. Yeah, let's see. You see, we wanted to have the picture of circle excluding this part. Right now we have picture of this, of circle for x is smaller than 0 or always negative. Why? Because of the order. Here intentionally I make mistake, because here R took this as this argument is true, this and this, or only this. So I mentioned this before in when we discuss logical tests, that if we want, we have to be very careful, and AND operator is like multiplication, OR operator is like addition. Yes, so if we want to have that this condition is true and this or this, we have to use brackets. Okay, and now we will get here, yeah, or this condition is true. Yeah, and this is what we wanted to obtain. Yeah, so in our exercise it's enough to add this condition, and in the brackets one of those conditions is met. Yeah, and this is our code. Yeah, that should work just fine. Circle frac MC, and let's say we have 10,000 points. We have this number, which approximately should be equal to 75% of pi for radius 1. Yeah, so if we type 75% times pi, yeah, we get quite close to this number. If we increase the number of points here, we will get even closer. Yeah, so that's question 3. In question 4, you are asked to draw one element from a vector of 4 strings. Yeah, and it's super easy. Function. Okay. So here we will use function sample, and here we will sample from this vector of 4 economists. Yeah, so let's call this random economist generator, and we want to draw only one element. Yeah, so sample size What's that wasn't necessary, yeah, in the definition. Yeah. And now should work. Yeah, this is the first part of the exercise. In the second part of the exercise, let's use this randomize. Let's create function randomize2, and here probabilities for drawing Sargent, Lucas or Lange should be 0.20 for each, and for Nancy Stocky it should be remaining, which is 0.4. Yeah. And so here we use this function prop. Okay, and this is it. Randomize 2. Yeah, and yeah, one idea came to my mind here that we can do. It's not in the question, but let's check whether this randomization indeed is that those for economists, for function randomize is chosen with equal probabilities, and whether indeed for Stocky this probability is twice as large as for the remaining economists for function randomize 2. Yeah, so to check this, we can basically use the function that we already know, replicate, and let's use this function, the first function, outcome or simulation 1. So now I'm saying that I ask R to run this replicate function 10,000 times and assign randomize here, randomize. Okay, yeah, okay, so here the result of this simulation 1 is that, yeah, this was repeated many times, and if we type table simulation 1 and prop table, yeah, we see that more or less probabilities are equal. Yeah, if we for smaller number, those discrepancies can be larger. Yeah, but the larger number of simulations, the larger this number is, those discrepancies are smaller and smaller. And let's repeat the same exercise with function randomize 2. Yeah, you see, probabilities for Lange, Lucas, and Sargent are around 0.20, while for Nancy Stocky is 0.40. Yeah, and but yeah, you weren't asked to do it. Yeah, but I wanted to show you yeah, this tiny digression. In question 5, I think that this is question, yeah. In question 5, we are asked to create converter of Celsius degree to Fahrenheit degrees and vice versa. And depending on and also we should provide what type of conversion we want to obtain. Yeah. So we create function convert. This is function with argument. The first argument is degrees, and the second argument is type. And we are asked to make conversion Celsius to Fahrenheit the default one. And we do it by typing the value of the default value for type. Yeah. So this is our function, and now if type is equal to C to F, Celsius to the degree, then output should be what? We have in the assignment we have function for this, and this is, always I forget, without exact numbers, yes, something like this, yeah, and if type is F2C, then the conversion is a bit different, namely we should have degrees minus 32 times times 5 over 9, yeah, and then we return output. Did you find this? Okay, and now if we type convert 0 type C to F, we should get 32. Sorry, convert 32, yeah, from this formula, yeah, and on the other hand, if we type C, we should get 0, yeah, and again, here default type is C to F, yeah, but what's the problem? The problem is that this function is not it's not proof to some mistakes made by users. For instance, if I type 0 type, I forgot that there are only two types, C2F or F2C, I get some error message because none of those conditions are true, so I cannot return the output which is defined inside this if statement. Yeah, so to make it true, to make it work even with this type equal to Mannheim, and again, now this for assignment, this is just fine. But now I'm saying how this function can be improved even more. If we type here else if and else, and then we write warning. This is function warning that generates warning. It's quite similar to print. I don't want to describe the differences, but here we can type warning. The provided input type is invalid. Yeah. So in case of that none of those conditions are true, then we have this warning message. Yeah. So let's create this function, convert to, and now if we type convert to here, we will get the error message. Yeah. Sorry, we will get the error message, but still here we try to return the object. So to make it to avoid this, we can move this line, not which is run always, but we can type this here and here. So in this sense, we eliminate the possibility that if none of those types are provided, then we will try to return this object. Yeah. So let's do it once again. Okay. Yeah. And converted, the provided input is invalid. Yeah. That's it. Yeah. And yeah. So this is a solution to question 5, I guess. Yeah. In question 6, we are supposed to create function generate, which is function without any input argument. And first, in this sorry, in this function we have to first draw one number x, and depending condition on the realization of x of our x, which y should be generated in different way. Yeah, so first we generate we draw one number from that is assigned to x from 1 to 100, and now if x is even, if the drawn x is even, so if it is 2, 4, 6 and so on, then there should be one condition. That's the first condition. Else if x is equal to 17, then we will have y equal to 1. And in other cases we will have some block. This is the third point. So how to check whether x is equal is even? We can, there are several ways, and I will present you two notations. The first is that if we use modulo operator and divide by 2, it should be 0. Yeah? If we write 2, it's 0 for even numbers, but for odd numbers it's 1. Yeah? So this is how we can check whether x is even. Yeah? And if x is even, then we are supposed to that y is sampled from set of two values with equal probabilities. Yeah, so we don't have to provide probabilities, and we write size equal to 1. Okay, so those are two conditions, and if in point 3, in all other cases, the value y is sampled from set from 3 element sample with probabilities 0.1, 0.5, and 0.4, and we do it this way. Sample set is 12, 14, 21. Props are 0.1, 0.5, 0.4, and size is equal to 1. And last but not least, we generate x and y, and what is returned? We want to return both things. So we have to write return and a vector of x and y. Yeah. Generate. Yeah. This is, we draw x which is odd, which means that none of those the first two conditions are met. So only possible values that are generated are 12, 14, and 21, and it is 21, one of possible. Yeah. For 81, yeah, it's the same. Here is the third condition. 50 or 55, still, yeah, all numbers are odd. Yeah, it was quite suspicious. Yeah, but you never know. You always can draw so many odd numbers. Here, yeah, we draw 92, yeah, which is even number. Yeah, and here we enter to this condition. Yeah, and we sample from two element set 5 and 10. Yeah, and it's 10. Yeah, it makes sense. Yeah, and generate. Yeah, 2. Then we generate only even numbers. Oh, okay. It's odd again, and again it's from this interval. Yeah. So this is it. Alternatively, to this condition, we could write that, suppose that we have even number, yeah, and in here, that's true, but the same thing can be obtained using in and sec 100 by step 2. And then we do it in more explicit way. We generate all even numbers in the interval from 1 to 100, so all numbers that are even in this interval, and we check whether our value is in this vector. Yeah, so this is more explicit than this. Yeah, this is more elegant, I would say. Yeah, and the last question is, I would say it's super easy. Question 7, and here we have to generate function, what's gensec function, and we take as input x0 and n, and in the first case, yeah, it's enough that we take x0 as the starting point. By step, we increase each next element by 1, and length. Sorry, and we use sec. Return this and sec. Yeah, this is how it works. And if we want to do sec2, if we want to have increment by 1.5, this is it. If you know the function sec for sequence, yeah, then it's very easy. Yeah. Yeah. So this those are solutions to the assignment. I ask you to try to do it. Yeah, and now, yeah, I think that this is it for this part. Yeah, so see you in the next part.